Hey y'all, so we're going to go ahead and do a quick screencastify just so I can kind of show you a little bit of what we went over today and just to kind of see how easy it is to go back and forth between the two tabs. So the two things you need to have open right now are the ramp and roll lab graph, the one that was attached to today's to-dos in science from today, from 10/6. The other thing you're going to need is your um, lab report, the one that you have been working on for the last week. This is mine. This is my example one right here. So my ball and ramp lab, put my name on it. I filled out my hypothesis. I conducted my lab. I wrote that my ramp was 5 centimeters tall. Again, yours may be different. And this is my data chart. This is where I went through and I typed in my data. I said, okay, let me see how long this takes to roll down from 10 centimeters. Start, stop, start, stop. And I went ahead and did that for all of my first 3 columns. And then I averaged them by adding them together, dividing by 3 to come up with my average time. And then I divided my distance, 10 centimeters, by my average time, 0.85 seconds. And I came up with my speed here. And everybody right now should be in this place. If you're not, review my video that I posted to my YouTube channel um, on Friday, which was the 2nd, I think, something like that. All right, so from here, what do we do? Well, I made it super easy for you by Mr. Beans actually created this document for me. And this is for you to just go ahead and put your information in here and it will automatically average your time and automatically calculate your speed. So how am I going to do that? Well, here's my data chart. So I'm going to go like this. My distances were 10, 20, 30, 40, and 50. So I want to go here and put in 10, 20, 30, 40, and 50. If your distances are different, just go ahead and double click that and change it. Now, my first one is going to be 0.85, or excuse me, 0.83, then 0.9. So I'm going to go here. Trial 1 was 0.83. Trial 2 was 0.9. I'm going to come back here. Next trial is 0.83. 0.83. Now check this out. It automatically averaged your time and it automatically calculated your speed. I mean, how much easier can that be, right? So now I'm going to go here for my second one, and that's 1.11, 1.10, and 1.20. So here we go here, and that was 1.11, 1.10, and 1.20. Now I'm ignoring my graph for now because it's just going to continue doing wonky things. So we're just going to ignore it for now. So my third launch zone was 1.32, 1.39. So this one is 1.32, 1.39. Or if you wanted to like take a picture or something or use multiple screens so you don't have to keep coming back and forth, knock yourself out. And that's 1.51 for my last one. 1.51. And then finally, or not finally, but next, 1.6, 1.59, 1.6, 1.59, and then 1.61, 1.61. So really all we're doing is taking the data you already gathered and just putting it into a spreadsheet. And then that spreadsheet will calculate a graph for you. So finally 1.79, 1.8, 1.76. All right, 1.79, 1.8, 1.76. Now, before I go any further and look at my graph, I want to make sure that the average times that I calculated were the same as the overall speed that I calculated. So these are the numbers that I came up with when I did the math, but let's see if they match what the computer came up with. And if it's not, the computer's probably right. So let's see, 0.85 and 11.76, 0.85, 11.72, what? So let me make sure, let me 0.83, 9.83, 0.83, 9.83. I guess they made I guess I made a mistake. So 11.72 is not right. So I'm going to come back here. I'm going to change that to 11.72. Make sense? So we're going to go ahead and make sure everything else matches. Okay. Whoops. Something went wrong here. There you go. Okay. It didn't finish. There you go. All right. So everything else matches. Everything looks good. So now what? Well, just based on my graph right here, I can see, or my chart, I mean, I can see that my average speed increased. For the greater the distance, my marble went faster and faster and faster. And I can see right here, that's what the graph says too. Now, what are you going to do for your graph? Well, now's the time for you to kind of adjust this to make sure it fits you. It will put your components in automatically so you don't have to go back and change anything. Distance on the bottom, time on the top, because distance is what we changed. That was our independent variable, and time was our y-axis. That was our dependent variable. But look, this says marble's speed. Did you use a marble? If not, you're going to want to change that. You're going to want to change that to, say, my pencil if you roll your pencil down, or my chapstick if you rolled your chapstick tube down, or my tennis ball, whatever you're going to put right here. And then also the title of the ramp of the lab itself if you want to change it. If this is kind of cumbersome, time it takes to travel distances down the ramp. I'm going to change that. I'm going to say how to find speed through a rolling ball or a rolling marble. Or maybe you're going to say how height affects speed. Or maybe you're going to, whatever your title is works for me, as long as it makes sense to you and it's clear. So please don't say something like ball lab. It should have something having to do with speed or rolling or moving or marbles or pencils or whatever it is that you're doing. So uh, distance versus time relationship. Ooh, that's a good one. Right now, if you want to keep the same title that I already have, that's fine too. This is just kind of make it yours. All right. So that's where we are so far today. Tomorrow, we're going to be looking at what this information means and see if we can figure out if our hypothesis that we came up originally was right or not. So again, we're just kind of going back and forth between our ramp and roll lab, chink, chink, chink. We're putting that stuff in here, yada, 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 and bam, it does it for you. If you get stuck with this, if you want to do it by hand, please feel free to do it by hand. I taught you guys how to do that in class today. So with that, I will see you later, and thanks for joining me. Bye.